Hello everyone, and welcome to another edition of Threat Thursday. This week, we are happy to announce an alliance with C5 Health to give back to the healthcare community. In relation to Threat Thursday, what we are doing is looking at a threat actor that has been targeting the healthcare industry for the past few years. That threat actor is called Orangeworm. Orangeworm is a lower sophistication threat actor, and as usual, we'll start with them and then get to more sophisticated threat actors so that the healthcare industry can emulate these actors in their environments. Orangeworm lives off the land. That means it gets onto a target system and uses built-in tools to gain and achieve its objectives. First, it does discovery or gains situational awareness, both of the local system, the domain, and the network it's on. Then it uses built-in tools to create a local account for persistence, as well as create a service that will run every time the system's booted up. This, of course, goes along with a blog post that dives deeper into this threat actor. In this demo, we're going to import Orangeworm and run it against two environments. One is a system that's joined to a domain, and the other one's a system that's not joined to the domain, so that you can see the differences when you do adversary emulation against those two types of systems. We hope you enjoy. So we'll start in our SCYTHE dashboard, and we'll go over to Migrate Threats, where I've already imported the Orangeworm threat that's available on our Community Threats GitHub. We go over to the threat catalog, and we choose Orangeworm. Here we can read a little bit more about what this threat actor does. As I mentioned, it uses a lot of built-in tools such as command line execution, the net command, the host name command, who am I, directory commands. Things are built into the command line to gain situational awareness first of the local system, then of the domain, then of the network, and then it uses those same commands to obtain persistence by creating a new user. So we click Create Campaign from Threat. We'll call this Orangeworm, fill in our IP address, and we will start our campaign. Now this campaign executes with DLL, so we're going to copy that download link for the 32-bit DLL, and we're going to execute this on two systems. One system that's joined to a domain and one system that's not. To execute, we use run DLL32 and execute the service login.dll we have just downloaded. If we come over to our dashboard, we see both systems have checked in. All right, we've given that some time to run, so let's take a look. First, we'll look at the machine that's not joined to the domain. We scroll down to see the beginning and see that it has gone through and acquired information such as host name, who am I, net users. You can see the different users are there, but then some of these failed. And here you can see the net user / domain command failed because this system's not joined to the domain. Go through, and of course it has acquired quite a bit of information for all of these commands that have been ran. Some of them failed. Those again are because they are against the domain. Now, as we mentioned, we don't want to do persistence in an automated fashion. We want to do that manually. If not, we're going to try to persist on top of our persistence. So to do that, we can pull up a shell. So we've pasted in here the command. It's net user, the username we're creating, the password, and /add. And we see this command completed successfully. Now we want to add this user to the local admin group. To add the user to a local admin group, we again run command /c net local group administrators, the username /add. And we see that command completed successfully. We can then run the net local group administrators to make sure that we are indeed now a local admin, and we can see that there. For persistence, we're going to load the persist module with loader -- load persist. To use the persist module, we will run the persist command. This will create a new service, which is what Orangeworm would do to gain persistence apart from creating a new account. The syntax is persist dash dash the host name dash the name. We'll call it SCYTHE, same display name, description. Of course, you can be as creative as you want here. And we'll write this to Windows temp SCYTHE.exe. And the persist was successful. We can go over to see Windows temp and see that SCYTHE.exe is there. Now, let's go back over to a system that is joined to the domain so that we can take a look at those commands that weren't successful on a system that was not. Users. And now we're getting the domain password policy. In this case, this one worked. As well as getting all the groups within this domain. You can see all the various domain groups. And we can see who's a member of the domain admins. We see Georgie is one of those there. And if there's any domain trusts. So all of this was done with living off the land. These are built-in tools that come with Windows that on their own is very difficult to prevent, but you may be able to detect when this attack chain occurs. So this covers our Threat Thursday. If it's the first time watching, welcome. And if you are in the healthcare industry, please reach out to us. We have an awesome deal for you where we will work together and be able to do some of these adversary emulations in your environment to see how you can detect and prevent these types of attacks. I'd like to thank you for your time. Please follow us on Twitter, Scythe_IO or George Orchillas. Thank you again and have a wonderful day.